Welcome back to our Scala class, and today we will go deeper into functional programming. We'll talk about partial functions, we'll talk about apply and collect methods. So welcome back to our Scala and Spark advanced course, and let's go back to our IntelliJ as usual. So we'll start. We covered some of the collection methods previously, and we'll go deeper into some more extra methods. I'll start a new file, of course, new object, new Scala class, object, and we'll call it day 4, partial fun. So fun, but it's not full fun, right? So, and this will be our, I'll do extends app, of course, again, and we'll do exploring partial functions, right? But before we get to partial functions, we will want to look at apply. What in the world is apply? Because we'll come across it. So also, first let me run this. Right. I will create a companion file, an object. I'll do it, a new file. Let's make a new object, Scala class, object, day 4, object, apply, right? Something like this, and we'll talk about that first, because we'll come across it later. This will be just a helper, right? So this will be something, we're not going to run it, it's just something, it's a singleton object, so a single instance, something we'll use, right? And I'll have, maybe I have a variable here, right? I will have a variable maybe like, you know, I don't know, x, right? It will be 1, right? And I could use it, right? Here. I could use, of course, I could access it. So day 4 partial object apply, right? It's public, right? X, right? And I could do maybe plus equal 5, right? And print line day 4 object apply, right? And x, right? And this should be 6. Should be 6, right? And of course this should be 1, right? You know, just using it for data storage, right? Nothing too fancy, right? It's a mutable variable, right? So we can see what's in there. Let's see if this actually works. It should. I shouldn't expect any major surprises. Yes, and it works, right? Okay. All right. So we can actually to simplify things, and also, well, to simplify and also to add some extra abstraction. We could also say we can complicate things. It comes from mathematics. We can use something called apply function, meaning so we can use this as a sort of bridging the gap between functional programming and object-oriented programming, right? We would like to call day 4 object apply as a, you know, similar how we would call a method inside it, right? So what we do for that, right? Something like, you know, day 4 object apply, maybe, you know, I don't know, you know, 5 to add 5, right? Okay, so what do? We basically add an apply method. Really simple, right? Hopefully I can do it correctly from my hand. Apply, right? And I'll do what? The integer, I don't know, y, integer, right? And it will be x plus y. I believe that will be correct. Let's check if that's correct. Yes. Or did I do it correctly? Let's see. And I had it somewhere here. Where is it? Factory depend, right? Something, apply, right? It should work. Let's see. Let's see if this actually will work. Okay, something like this. This is from early 2010s, right? This has been but it should still be applicable, right? So we'll see how this is, right? So, oh yeah, returning integer, right? Integer, right? Of course, right? Signature. Okay. Okay, looks okay, right? So we have an internal mutable, you know, state data, right? And we have defined an apply function. So the whole idea is that now we can call it. It should work now. Let's try this. Day for object apply. Can I do this? I'll do 20, right? Yeah, looks like it's correct. Now it works. And I should be able to, it should be 16 now, right? Let's see if that's really the case. So, like this. And it is not 16 actually. It works, but actually right. It returns this, right? So this is actually new value, new val, right? This is actually here, right? It's not 16, it's actually 6, right? But this should be, it's an integer, right? Makes more sense, right? So print line, new val, right? So this should be 16, right? This is new val, right? This should be 16. This should be 16, right? Right. Yeah, so this is indeed 16. Okay, right. So it takes the internal state and we return, right? Makes sense. We're returning something, right? So all it is, it's really, so this is, so basically, so it should be exactly, so this also, this also, same from apply, right, will be, so day for object, it should be basically apply, right, same thing, right, exactly the same, right. So basically, so we apply functions as syntactic sugar, basically, right. We don't have to, so basically we don't have to type apply, we can actually, you know, just use directly like this. Okay, so it's so this calls apply, right? Now just like this, right? Same as above line, right? So we could see from apply, right? Then also 16, right? And of course the data inside is still 6. We could of course add some side effects, right? Right, 16. Right, of course, if I want to get crazy, I could add some side effects and I mean, it's not unmodified, do some mutations. Of course, I could add some more, you know, more lines of plus y, so plus y, right? Right, more instructions here, of course, right? To apply, right? It's just like regular method, right? All it is, we gain some syntactic sugar, right? So we gain syntactic sugar. Oh, sorry, my mouse froze on. We can use it. So yeah. So if you want your objects, including this one too, right, to be callable like this, you can create an apply function. So again, it comes from mathematics because mathematicians like to talk about this applying something, right, to a function applying, like this is nicely said here, right? Apply the function, applies function to arguments, basically, right? So basically, again, here's an example, is like this, right? When we call list, right, we actually doing this, right? It's hidden, so apply is almost everywhere underneath in our objects, right? So again, apply is simply a method we define for some object, right? And then we can use it to call directly. To have this object, we can call it directly with this argument, with this particular some argument, right? Okay, so you can play around with this, right? And of course, again, needless to say, I mean, I could just print line, of course, print line, day for object. So let's see, let's add some more data. Let's modify something, let's add something like this. Let's add maybe 100, right? We'll do some mutations. And of course now if I do print line, day 40 object apply, or day 4, not a great name of course, and I can do maybe, I don't know, 200. So this should be what? Should be we had 6, so it should be 306. So this should print 306, right? Right, mutate now. Internal state x is now 106, right? And we should print 106, right? You know, x is still 106, right? Again, just to drive down the point again. Nothing too crazy, right? Right, x is still. Okay, let's see if this is really the case. Yes. Okay, so this is 306. So my hypothesis was correct, and 106 is still present. So internal state isn't. Okay, right. So now that we are done with this short introduction to our apply method, let's move on to collect. Right, and we'll get to the collect first. So partial fun. So the idea of partial fun is that we have a function that is not defined everywhere, right? So a partial function is a function that is not defined everywhere. I'll be using this from Scala cookbook by Alvin Alexander, of course, which we know very well by now. It's a way of begin. So we have all this is going to be a function which does not provide an answer. I mean, it is not defined in for every possible value, right? Well, classical example, of course, will be a division, right? Because you can't divide by a 0, right? So, yeah. So, this is from, let me give it a link. Very nice, so you can see this. So, right. And let me copy this too, right? So you can see. And we will have some fun with these. We'll have some partial fun. Okay, that's too much. All right, we can do this. Yeah, okay, great. All right, and let me commit this first. Day 4 apply method. Explained. Right? Commit and push. Right, and now we move on to we'll create some simple we'll create a divide function, right? We could do this, right? Okay, def divide fun, and I could do, of course, you know, let's say n int, and it would be, of course, return int probably, right? And it would be, let's say, 9,000 divided by n, right? Right, and we can, of course, do print line, you know, 5, you know, which will work, right? And print line 0. Oh, sorry, of course, divide fun. Of course, divide fun. Here we go. One more parenthesis, right? This should work. Should be 1800, right? And this should be something like, this should throw us an exception, right? I'm getting to an exception. This should throw an exception, right? Let's see if we get an exception. Yes, indeed, we got an exception, right? And throw an exception, mathematics division by 0 exception, arithmetic exception. So we could use this. So we could use try catch, you know, of course, as we know very well, Scala try catch, right? We know this, right? In the books, right? We could use this, right? This is what we learned in a previous course, try catch, classical object-oriented style. But we have an alternative, right? Again, Scala is all about alternatives. We could move on to using this partial function, defining a function partially, right? So just, you know, as in, right, as discussed previously, right? So I'll comment this out. Okay, so the idea is this: we are going to define a function slightly separately, right? First of all, to get there, I will actually create the function slightly differently. Like this was our classical way is defined. You notice this sometimes before we can define functions, right? We can define functions as using anonymous function syntax, right? So also this is also going to be divide fun2, right? I could do this. It's not defined, but val divide fun2, right? And so this is just like a value, right? So what's happening? I'm going to say, okay, this is a value, okay, so n or x, whatever, right? N integer, right? On return, 9,000, by n, right? Right? And this is also legal. So basically, so I said value, divide fun2 actually, points to points to a function, right? Which we just defined anonymously. Right? So that's also, so this is an alternative syntax. We see it sometimes, right? So again, define a function like this or like this, right? And of course here what's difference is, of course, we didn't get defined style, right? So it'll work. There's nothing different. Still the same problems, still same solutions. So I can do again divide fun2, right? This will be again 1800, right? On print line divide fun2 0, same problem again, same problem, right? Same problem with exception, right? Let's see if that really is the case. But yeah, it's still the case. Let's see, is the line correct? Yes, it is. Arithmetic expression 29, right? Here it says, okay, this is the problem here, right? 31 actually, right? But we jumped, the problem was here. Okay, so interestingly enough, right, you can see even here apply always shows up, right? Because I'm using extends. The app also has this also has an apply function, right? So okay, so again, we could use this divide and catch, but we'll use a slightly different approach. We'll use this partial approach, right? Okay, so how do we define? We'll do it partial. So val divide partial, right? I'll just call it partial equals going to be new partial function, right? Now I need to define what's going on, right? So and I need to tell basically the syntax is kind of funny. So I have to say what's going to be inside int, right? And outcomes int, right? So you need to use this syntax, right? And now I need to define it like this. Wow. So let's see, maybe something not correct. Maybe I made a mistake here. Divide partial. Let's see. Apply. Okay, it says basically I have not. I need to apply, define, apply, and I'll do the same thing, right? The function, right? And we'll notice, n integer, right? Equals, 9,000 divided by n, right? Okay. Are we in good bed? Are we done yet? Not yet. Not just yet. All right. Okay, so what else have we done, right? Yes, you see, it's actually telling me what I have not done. So basically, I need to define two. So partial function needs to define two methods. Apply, and also is defined at. Those are two requirements. So I need to make another one. So I'll make is defined at. Yes, correct. No, control not, I don't need override, is defined at, right? On so again, and into whatever you want, use x or n, doesn't matter, right? And this is gonna be a Boolean, right? Is, right? That's a Boolean, right? So n not equal 0, right? It's a Boolean function, right? It should probably say, do we not add type annotation? It's a Boolean, right? Okay, and now everything is good, right? Which returns Boolean depending on, you know, whether we accept this incoming you know, function argument, you know. In this case, it can be 0, right? In this case, right, we do not divide by 0. So all it is really, it's a structured way of providing some logic for, you know, for functions which don't have a fully, you know, which do not accept all possible arguments. Like, for example, you know, classical way, we have an integer to, you know, integer comes in, something comes out, integer comes out. Well, we can't take all integers, right? So this is just a way of structuring this logic, right? So applies what to do, so what to do on what is not acceptable, right? Again, notice Boolean, right? And so of course you could have more logic here, of course, obviously, and also same thing, right? Again, so integer in, integer out. So this is actually what is gonna do the work. So let's see how it works, right? So let's do this. Print line. Will it work? Print divide partial. Again, I'll do, what is it? Of course, p. Let's say again, there 5 should be 1800. Again, should be 1800 again, right? Let's see if this is really the case. Did I do everything correctly? Again, I don't use these too often, but so yeah, 1800, okay. And well, so let's see what happens now. Right, it still will throw an error, right? Because nothing really changed. I mean, there's no magic here, right? No. This will also throw still an exception. Again, an exception. Right. Okay. Which is again. So what did we gain? Right. What did we gain by all of this extra work? Right. The way we do is basically we gain legibility. Right. We gain abstraction. We gain abstraction. Right. Or error checking, you know, of error conditions checking, right? By using this special, you know, strictly defined function, this method, right? Again, we can use this syntax, right? So if it's partial function, right, we can check. So what do we do? So this is, well, we are gonna do basically use if, right? If, so print line, if basically you do this if let's say we have an incoming argument, let's say, right, you know, my argument, you know, while arg is equals 0, right, you know, if, you know, divide partial is, let's see, I can type divide, I see I can type, right, is defined at arg, right, then print, right, line result, you know, result is, you know, something like you know, arg, right, and semicolon, right, else, right, sorry, S, right, define for, you know, divide partial function, right? And that's all it really is, right? So it's just a way of again, this logic for what's good or not good is defined. It lives here, it lives in a strictly defined place, right? Not in just some arbitrary if, right? It's actually in a special method call. That's all it really is, right? So you gain this special, well, that's not all you gain. We'll see. We'll gain some other things. But for now, right, we'll see this. It gains a special place to live, right? Let's see. So we gain the ability, right? Sorry, 0 is not defined for divide partial function, right? So of course, if I add 10, right, it's not right. We gain this, right? This Boolean returns. So if I add some other argument, I'll get 900, and of course this will be 900, right? Yeah, result is 900, right? Of course. Okay, so we basically gain ability to check using this function. Again, strictly defined. Strictly defined on, so we can check on validity of our data. Okay, again, nobody is requiring you do this for every possible data processing function, but again, it's something to keep in mind if you sometimes encounter this, right? So again, so where else can you see these partial functions? Well, you can actually see them. You can run into these partial functions in when you're doing match, right? If you forget to, you can run into partial functions if you have a match pattern matching, right? Pattern matching where you do not cover the default case, basically, right? Because of course you don't cover all the possible cases, right? Okay, so right, so we have definition, right? And we can actually basically we have the apply, basically. Okay, right. So let's see about let's see let's see how much time we have actually first, right? So we have this. Oh, we can do this. Okay, right. So we can use it to combine combine two different. We can have multiple partial functions, and we can combine them together, right? So again, this is a very silly example, but right, but again, of course, which we could use with a mapping, but this book gives this very silly example. I'll just copy and paste this because this is really somewhere where is it? Okay, it's defined. We saw this, right? We did all of this stuff. Is defined at true, false, right? So right. Oh, there's a match example somewhere, right? Yeah. Right. Yeah, right. So so interestingly enough, yeah, we can do the same thing using this, right? So if we have a function, right, but we don't actually return everything, right? Integer comes in, right? Right, you can actually use this syntax as well, right? Using this, we have a case D, right? But we don't have a incoming. That's the argument, basically, right? But nothing. If D is not divided by 0, right? And then because you're not covering 0, the case 0, default case is not covered. I guess I can show you this as well, this example, right? So this alternative way of writing, right? So something like this, right? So divide 2, right? Partial function, right? It's a partial function, and here you have anonymous definition, right? So where the heck did this D come from? It's just an argument. It's basically a hidden argument, case D, right? It's coming in, right? So we can use it again. So print line, divide 2, maybe 300, right? Should be 300, should be 30, should be return, should print 30. I'll do 9,000 here, of course, right? 9,000. We can print 9,000, right? Let's see. Print 9,000. I'm sorry, 30. It should print 30. Yeah, it is prints 30, and of course, again, it will. Let's check. Print line divide 2 is defined at yes 0, right? 1. Control D 1, right? and so on, right? Yeah, so false true. So this is an extremely short way of writing this, right? You don't have to, so this has both apply and is defined also. Again, very, very convenient, right? Question is, do you need, is this D really important? No, it doesn't matter, right? I can do this maybe X, right? Refactor, rename, you know, X or N, doesn't matter, right? This is going to be an error? No, it's not going to be an error, right? Right, it's true, false, okay. So that's an alter, right? So shorter. So apply on is defined at come, you know, are free here, you know. So basically saying this is a function. Divide 2 is a type partial function which takes integer as input and takes out integer. And then automatically, you know, here's a little bit of magic, right? You say, okay, we're doing pattern matching. We're only covering one particular case, which is case, you know, which is when it's, because this part here, right, if the value is integer, only if x is not equal to 0, right? Of course, technically, if I didn't do this, I mean, it would still be a partial function, except it would be a full partial function, right? I mean, it would be kind of useless as partial function, right? If I took this off, right, it would be a full partial function. Okay, right. So let's see about if else and then. Let's go talk about that. We can use this. So we can use chain. We can combine multiple partial functions to process some data, right? So let's see. So we are going to define this example here somewhere. They had them examples, right? Of, else, and then, right? So these will be kind of silly functions, but okay, let's go with it, right? I'm going to copy these because I'm lazy, right? It's a convert 1 to 2. And let's get num. Okay, I could do a type annotation, right? It's an array of string, of course, right? Again, so this is you rename to numbers. I'll do numbers. Okay, thank you. Right, string add annotation. Again, you can see add type annotation. Now we are good, right? Okay, and I will do also another one here. Convert x to 6. Again, these are kind of silly functions, but for learning purposes. Again, I'll add type annotation, and I will rename them. Again, numbers doesn't really matter, but I like the spelling is not it's correct. So we have defined very strictly too strict from 6 to 10, right? And we have defined notice the indexing here, right? Numbers I minus 6. That's very interesting, actually. What's going on here? That we are actually, so we have defined this, right? An array of strings I minus 6, right? So function, it's a partial function. In comes integer, out comes string, right? And this apply, yes, it takes from this array and takes I minus 1. So a little bit of magic here going on, right? Well, or is it magic? No, let's think about this, right? So it's very, you have, of course, here you have to be careful. Of course, here you would have to be careful with the bounds, right? So what's happening? Somebody enters 6. 6 minus 6 is 0. So you have the array 0, the first item out of this particular function, right? This partial function, right? Here you have item number 1, right? You have this. Well, again, it's very strictly defined, right? And so indexing will work, right? You'll have proper, again, I'm not really a big fan of these functions in general, but this particular example, but again, it works. And just demonstrate what's going to happen. We can combine these, right? We can combine them, right? Because they each handle 5 numbers each, right? Yeah, but we can combine them, right? So that's a cool part, right? So let's try this. Basically, and this is in a functional way. Functional way. What we can do is this is the cool part. Okay, val handle 1, 1 to 10, right? And this is going to be a function. So let's check this out. Or else convert 6 to 10. So now, we create, we combine these partial functions to create a new partial function. Right? Let's check if this really is the case. Is this a partial function? Indeed, it is a partial function that matches type. Again, so this is functional programming. Again, you don't have to use this type of way, but it's quite nice, right? Because it nicely explains what's going on, right? Assuming you wrote correctly. Okay, so this handle 1 to 10 is going to be convert 1 to 5 or convert 6 to 10. You don't have to write this again every day, but again, if you have this type of problem, you have multiple, some things handle certain amounts, right? You can create quite nice readable code, right? You pay the cost, the hard part is creating this structure here, but then on a higher level, that makes pretty nice, again, if you have nice function names, right? Very nice readable code, actually, right? So this is a partial function, and let's check if it really works. Okay, so print line. So handle 1 to 10, and I'll do something like 3, right? And I'll do Control D, I'll do maybe 8, right? So this will work. 3 and 8. Whoa, nice. Look at this. 3, right? So what happened? Okay, because this new combined function, okay, it says, okay, you're going to use this function, this partial function, because of the is defined area. The only, and of course, same for this 8. So 8 minus 6 is 2. So 0, 1, 2. And 8, you get an 8, right? Makes sense. Okay. Now, and so similarly, again, we had 3. So it was 0, 1, so 0, 1, 2, 3, right? So minus 1, so 3 minus 1 is 2, so 0, 1, 2, right? And you have a number 3. Okay. Again, of course, this is crucial. You have to match these limits, what you are accepting, with this, right? Otherwise, you'll have an exception. Okay, so no exceptions here for these values. But how about something which we don't handle, right? Except we say handle. Let's do something, 32, right? Or 40, something like this, right? So what will happen? It should be an exception, if I'm not mistaken. But let's see. Yes, it's an exception. What kind of exception? Array index out of bound exception, right? Index 34266 out of bounds for length 5, right? Because it ran out of. The question is which function. I wonder which function it ran. Did it run the first or second, right? Well, I don't know. Can you see it here? But yes, so you can still an exception, right? Still an exception. Array index out of bounds, right? So you would need to check is defined, right? So let's see. Of course, right? We can do this. Print line, handle is defined at 34232, right? Whatever it is, and of course, naturally false, right? Again, it'd be kind of strange if it's true. Again, of course, it is false. Okay, right? So you can use this to right. Okay, now we have everything, but now we get to the best. Well, not the best part, but really cool part, right? Here is we can use it to use it together with a collect. Let me get some numbers, right? I have a, maybe I'll do some numbers, right? We'll do maybe minus 6 to, 15, right? And to array, to array. So, of course, checking this, right? Checking this is defined at can get old pretty fast, right? Again, but we have something cool left in store, right? We have collect to operate on as a map plus filter at once, right? So that's what we are getting at. We get finally a good part, right? So we can do this, and my words, right? Number words will be, as you can imagine, some numbers. Collect, right? Collect. And so collect is just like map and filter, but it takes a partial function. We'll do handle 1 to 10, right? So collect works just accepts once a partial function as a parameter, and will give values in a new collection with the right type. But it should be what? Array of strings, right? Yes, it is array of strings. Excellent, right? So we'll give values in a new collection wherever the values are defined, where the arguments are defined. Okay, excellent. Let's see if this really works. So well, print line, number of words, right, will be make string. This is going to be array, and comma. Let's do comma, right? Okay. Let's see how this works. Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so works perfectly, right? Again, so what we learned is now we learn how to use the collect method, right? Builds a new array by applying a partial function to all elements of this array on which the function is defined. Okay, so question is, could we use some other use this? Do we have how much time we have? We are almost done, right? 40. Okay, we can do also this other method, right? This type. Let's do this syntax, right? We can try this, right? And let's try to do something one more time, right? So this will be a partial function. It will be integer to string, right? Right. We could do this, right? And let's do this. Int to string, right? And integer, right? And we'll do this case n, right? Case let's say 1, right? Case, say, I don't know, 15, right? Okay. Did I do it correctly? What did I do here? I didn't do it correctly. Let me check my index, my syntax. My syntax is slipping here. Case. Did I do it correctly? I didn't. Oh, case 1. What did it say here? Expect. Sorry. Yeah. Not. I'm used to the other syntax. Yeah, like this. Yeah. Okay. Right. Okay. So we have nothing else is covered, right? And now, what do we had? 15, right? And now let's run it. Well, new. Also, num words, right? Will be, right? Some numbers, right? Collect into string. Again, so it has to match, of course, this. Has to match this into string because, right? No, I mean it doesn't have to match here, by the way, right? Here we could use whatever, right? Because we have just different collection. If this was integer and we were giving these integers, also it would give you integers automatically, right? So let's see. And also num words, print line, also num words, make string, and comma, and it should be 1 and 15, right? And let's do case, I don't know, 8, 9, right? As you can see, 9, right? And I'll do, again, since I'm lazy, I'll do case -3, right? Okay. Yeah. So minus 3, 1, 9, 15. Again, so it filtered. So again, so collect filtered only those which had a definition, and then mapped using int to string partial function. Okay, so obviously you could do this map and filtering separately, right? You could do filter, but I think this is much, if you had this kind of, if you had a strict, you know, if you had the areas like in this example, right? Here, it's, you could pretty much, I would do filter and map, right? That's pretty easy, but still you have mapping. But here, right, collect is kind of nice because you have this partial, again, we have, so again, we have, notice, we have no case default value defined, right? You could play around, we could define more values, right? If I did this, right, if I did this, I would actually get everything, right? Let's try this one more time. Again, since I'm on the roll, right? If I had this, I'll define just, you know, case everything, default, right? So this is partial function. Since I like to break things, default, right? Well, right? Into string default, right? And this is a partial function with everything defined. Is everything defined, right? So it's strictly talking, it's a partial function, except, well, there's no exceptions, right? There's no exceptions, right? So this will be, right? Let's try one more. Everything, all num words will be, of course, some numbers. Collect int default, right? Yeah. And of course, print line, all num words. Make string, all num words, right, on like this. Okay, let's see if this works. It should, again. Yes, you see default val, default val, default val, val, default, default, and so on. And then occasionally you have a nice match. Okay, right. And of course here you don't really, I mean, it could be possible again. So what do you gain by this syntax, right? Well, you don't have to write ifs. I mean, it's a way, again, so you can, so this is a functional programming approach to, you know, to get to processing some data out of some subset of data, right? Without using ifs. You know, I mean, ifs explicitly. Yeah, I mean, the ifs are here, right? I mean, it's kind of nice. I mean, I like it. I use, of course, personally, again, I use map and filter much more, but this collect is quite a nice addition to your tools. Again, you don't have to use every day, but when you need it, it can make a nice, clean code, right? You write, just find a function, what you need processed, and again, maybe not everything. This, if you need everything here, if you need only some values like this, and you just use a collect over some collection. All right. Thank you all, and I'll think of a nice exercise for you to work on next.